What if something is happening right above us right now that we still can't explain? Not just distant stars or planets, but real bursts of energy so powerful that in a fraction of a second they can outshine entire galaxies. And the strangest thing is, they keep coming again and again. From the void of space, with no obvious source, with no clear reason. For decades, we've looked to the sky for answers. But the deeper we look into the universe, the more questions arise. These could be traces of collapsing stars, collisions of neutron stars, or maybe something that will completely shatter our understanding of physics.
How does everything work? How was the universe created? These questions have tormented humanity for generations. But it must be said that modern science has advanced quite far in answering the most important questions of the universe. Of course, we shouldn't think that there are no gaps left. Science is not yet able to explain everything, but it seems to us that it is moving toward this goal by leaps and bounds. To answer the questions of how everything works and how we were all created, we first need to understand, what exactly is this everything? In science, there is a concept called matter. Don't confuse it with material, which is used to make clothes or build houses. Here are the definitions given for this term. Matter is objective reality that exists outside of and independently from human consciousness, and it is also the substance that physical objects are made of. So it would be much more accurate to change our initial questions and ask, how was matter created, and what is matter made of? These questions are still tough, but knowing where to start will help you find the answers more easily. Let's try to go back 13.7 billion years to that stage of the universe's existence, which is considered to be the time of its birth. It is believed that the existence of the universe began from a vacuum state, devoid of matter and radiation. It is assumed that some hypothetical field filled all of space, taking on different values in arbitrary spatial regions, until a homogeneous configuration of this field randomly appeared. Immediately after that, this spatial region began to increase in size very rapidly. In just 1 second, our universe reached a size of about 1 centimeter in diameter. At that moment, the accumulated kinetic energy transformed into elementary particles flying outward, and the so-called Big Bang occurred. Before that, the universe went through a period called the Dark Ages, when it was as black as pitch. Space was filled with a shapeless mass consisting of 5 parts dark matter and 1 part hydrogen with helium, which became more rarefied as the universe expanded. The matter was slightly uneven in density, and gravity acted as an amplifier of these irregularities. Denser regions expanded more slowly than less dense ones. A few minutes after the Big Bang, the universe consisted of hydrogen and helium atoms, with a large amount of energy left over from the explosion. Now we can confidently say that hydrogen and helium are the 2 most common elements in the universe. After the Big Bang, the universe needed some time to cool down. As it cooled down, the force of gravity began to pull hydrogen together. Over time, gravity started pulling matter out of regions of the universe with low density and drawing it toward regions of high density, creating incredibly large clumps of matter. Some of these clumps were so massive that even 200 million years after their formation, hydrogen molecules kept colliding with each other at extremely high speeds. Inside these gas clusters, enough nuclear reactions were taking place to compress the matter even further and create a kind of glow. The condensing glowing gas gave birth to a star and at the same time became its fuel. That's how the first stars were born. The dark era ended, and the depths of space were illuminated by the burning hydrogen from the cores of young stars. All the matter we can study today originated with the ignition of the first stars. A serious boost of hydrogen and helium allowed those oldest stars to become much more massive than the stars forming now. It is believed that many of them could have contained the mass of several hundred suns. The giant stars forming now can weigh at most about 150 times the mass of our sun. The existence of the first generation of stars was short and full of drama. They lived only about 1 million years, as they quickly burned through their fuel, after which they went supernova or turned into a red giant. The energy from these catastrophic reactions was released in various forms of radiation, such as ultraviolet, visible light, or microwaves. In addition, charged particles such as neutrinos and protons burst out from the depths of dying stars and form what we call the solar wind. The processes inside a star are very complex, but to simplify, we can say that 2 hydrogen atoms combine to form a helium atom. When all the hydrogen is burned up, the star begins to die, turning into a red giant. However, helium is also capable of burning. So, when they react, 3 helium atoms can combine to form a carbon atom. A carbon atom and a helium atom can produce an oxygen atom, which in turn reacts with helium to produce a neon atom. A neon atom and a helium atom form a magnesium atom. The process of creating new elements does not stop until it reaches elements that cannot burn. For example, an element like iron cannot sustain reactions inside a star for this very reason. At this stage, the star reaches 9 or 10 times the size of our sun, first becoming a white dwarf and then a black dwarf. However, if a giant star has used up all its fuel and is left only with its iron core, it becomes so heavy that it cannot resist its own gravitational force. It is in this case that a supernova explosion occurs. For a moment, the core of such a star can heat up to billions of degrees Celsius. The iron atoms are compressed so closely together that their repulsion causes a tremendous explosion. No sunglasses will help. Scientists believe that the brightness of a supernova explosion can reach, just think about it, 6 trillion times that of our sun. Within the star, 26 elements are formed during its reaction, which are scattered during this explosion. But there are about 90 elements in the periodic table. So where do all the others come from? During the explosion, the star releases a huge amount of energy and neutrons, which allow heavy elements like gold and uranium to be formed. During the supernova explosion, all these elements are thrown out into space. The first stars made a crucial contribution to the formation of star systems like our solar system. Explosions deliver this peculiar building material to different parts of the universe, including all the elements known at the moment, some of which are born inside the star, some during the explosion, and others during their journey through the universe, in collisions with gas clouds, and so on. It's not easy to imagine, but the iron that makes up our planet, among other things, was born in the depths of a certain star, just like the elements that make up our bodies. Thus, we can conclude that the very first element in the universe was hydrogen. It was hydrogen that brought the first stars to life, and then, after countless reactions, gave rise to all the elements we know from chemistry class. It sounds poetic, but everything we see around us, including ourselves, is the product of dead stars breaking down. But don't think that this happened sometime in the distant past and that the process has stopped. Right now, while you go about your daily business, studying, working, or playing your favorite video games, the process of creating matter hasn't stopped. New stars and planets are forming throughout the universe, and it's impossible to imagine anything that could stop this eternal movement toward life. Well, actually, scientists do have a couple of ideas, and that's despite the fact that the very idea that we can understand anything in such a boundless ocean of space and time as our universe seems absurd at first glance. Imagine you're searching for a lost diamond on a beach. Every now and then it seems like something sparkled among the shimmering sea of sand, but it's just a shard of glass. and disappointment washes over you again. Why do you think we're painting such strange pictures in your mind's eye? That's exactly how you can describe the feelings of astronomers who are unsuccessfully trying to detect extraterrestrial signals. For years, scientists have been intently peering into the darkness through telescope eyepieces, but the meteor-streaked cosmos stubbornly remains silent, keeping its grim secrets hidden. However, sometimes the silence is broken by rare signals of unknown origin. It is important to understand that there are many objects in the universe capable of revealing themselves in one way or another, with blinding light, energetic pulsations, or radio bursts. And it is the latter that we will talk about now. What are these phenomena, and what sensation has recently shaken the scientific world? This fall, astronomers were baffled by unprecedented activity in space. In just a month and a half, more than 1,600 radio signals reached Earth, whereas previously, such messages at best numbered in the dozens. It got to the point where, in just 1 hour, the instruments recorded up to 150 signals. This shocked scientists, especially since fast radio bursts are considered the most inexplicable phenomenon in the universe. What are single radio pulses, and where do they come from? Fast radio bursts have been known to science for only a short time. They were discovered in 2007. Like many phenomena in astronomy, the discovery was made by accident during the analysis of data related to pulsar observations. The duration of the signal was only a few milliseconds, but the energy of the event that produced it is beyond description. It is equivalent to the amount of energy emitted by our star over several days. And all of that in just fractions of a second? Honestly, it's hard to believe. And yet the fact remains. The radio signal was detected, so astronomers began to study it. It took the group of scientists a whole 5 years to verify whether the FRB 010724 burst really came from deep space and wasn't caused, for example, by an ordinary electrical appliance. So, a detailed analysis showed that the radio burst, lasting less than 5 milliseconds, came from the depths of the dwarf galaxy known as the Small Magellanic Cloud. And the distance to the object that produced this signal was incredible, about 3 billion light years or 1 gigaparsec. Since no other signals were received, the group of scientists from the Commonwealth Scientific and Industrial Research Organization concluded that such phenomena are very rare in the universe. How wrong they were. First, let's take a step back and pay attention to the obvious discrepancy between the duration of the signal and the energy that produced it. Doctor of Physical and Mathematical Sciences, Professor of the Russian Academy of Sciences Sergei Popov, in his lectures, simultaneously mocks this paradox, claiming that such radio signals cannot possibly be the result of extraterrestrial life. You have to admit, it's completely illogical to spend such a huge amount of energy just to send a single signal. Then the next question is, what exactly is capable of generating such powerful radio bursts? To answer that, it's worth recalling the words of Sergei Popov, who reminds us that we've already encountered a similar phenomenon when studying gamma-ray bursts. In Soviet times, it was believed that this type of radiation was caused exclusively by atomic bomb explosions. That's why spy satellites were regularly launched to detect such bursts in order to warn the governments of countries involved in the Cold War about potential dangers. As it turned out, coincidence once again played a leading role here. Thanks to active monitoring of outer space, it was discovered that the sources of gamma-ray bursts can be objects millions of times more powerful than any atomic bomb, and these monsters are infinitely far from our planet. The final realization came only after 30 years of meticulous observations. At first, astronomers couldn't understand at all where the dozens of powerful signals were coming from. Either their source was within the boundaries of the solar system or far beyond our galaxy. Of course, because of this, there were people who speculated about messages from alien civilizations. Movies released in the 90s, such as Contact, also contributed to this kind of sentiment. Jodie Foster's character caught a signal in exactly this way, indicating intelligent life in the universe. However, it wasn't a gamma ray burst, but a radio burst. Well, it's like they could see into the future. However, we've gotten a bit off track. As for gamma ray bursts, scientists eventually figured out what phenomenon manifested itself in this way. It turned out to be a supernova explosion. But things aren't so rosy when it comes to radio bursts. If you take a close look at the graph showing the first radio signal of unknown origin, you can draw a conclusion. Its source is very far from Earth, and the energy that caused this burst is equal to 10 billion times the sun's luminosity in just 1 millisecond. What's even more interesting is, how could such power fit into the radio frequency range? For example, gamma ray bursts are much easier to explain, since they even occur on Earth during nuclear bomb detonations. And by the way, they barely show up at all in the radio range. Of course, this doesn't bring us any closer to solving the mystery of these bursts. Let me repeat, if this is an alien civilization, then it's extremely wasteful. To waste so much energy, literally throwing it to the wind. But, as with any important task, there were small obstacles on the way to solving this extra tricky crossword puzzle that confused the scientists. What funny mishap got in the way of the astronomical investigation this time? The fact is that at the Parkes Observatory in Australia, located in New South Wales, some inexplicable things were once discovered. The instruments began to pick up similar radio signals, and with strange regularity, they were attributed to all sorts of things: a passing airliner, lightning discharges, and more. But the answer turned out to be obvious. It was just a regular microwave oven used by the observatory staff. The hungry scientists would open the microwave door before it finished running. That's why radio waves would escape. The equipment would pick them up. When everything became clear, the astronomers started checking the very first signal, FRB 010724, also known as the Lorimer burst. But according to a detailed analysis, it turned out to be genuine and had nothing to do with terrestrial radio equipment. So is the Lorimer burst still the only one that has been detected so far? Of course not. In 2013, after a series of false reports, the sensors delighted astrophysicists again by detecting several more millisecond signals. After that, it was concluded that there are actually a lot of such bursts in the universe, possibly several thousand events per day. But the question remained, what is generating these signals? At the time, scientists could only determine the location from which some of the bursts originated. In 2019, a single pulse with the code number 180924 was detected. It turned out that it came from a distant galaxy in the constellation Grus, which is located 4 billion light-years away from the Sun. But in 2020, for the first time, a source was discovered that generated a monstrous burst. It was a neutron star with an incredibly strong magnetic field located in the Milky Way in the constellation Vulpecula. At the moment, scientists have no good news for the public. They still don't know for sure what causes these titanic bursts of radio waves, and there is no single scientific hypothesis. But there are several interesting hypotheses. First of all, it's worth mentioning the hypothesis of Avi Loeb, a professor at the Center for Astrophysics. Scientists believe that radio bursts may be the result of activity from certain stars in our galaxy. An alternative opinion suggests that extragalactic sources are to blame, for example, some exotic events, the collision of neutron stars, the transformation of a supermassive pulsar into a black hole, or the result of magnetar activity. As you can see, there's nothing about extraterrestrial civilizations. But don't think that during this time scientists haven't achieved anything. Now we have the ability to detect signals from the same source as well as catch radio bursts more frequently. Very soon things will progress more quickly thanks to the Chinese telescope FAST, as well as the Keim radio telescope located in British Columbia, one of the provinces of Canada. The latter is capable of efficiently scanning the sky detecting new radio bursts. As for the spherical telescope located in China's Guizhou province, it will serve not only as a signal detector, but will also allow scientists to study the evolution of dark matter in distant galaxies, as well as solve other scientific problems. By the way, just a few years ago, anyone could take part in the search for radio signals. What did you need for that? Just join the SETI project, which allows you to catch radio bursts without leaving your home. This nonprofit platform operated on the basis of the BOINC program, using the computing power of home computers. Unfortunately, at the moment, the project is on hold. Since April 2020, SETI Home has stopped sending tasks to its users, but there are several alternative options for searching for gravitational waves, as well as creating a three-dimensional model of stellar streams. Finally, it is worth noting that the hypotheses put forward by some scientists are questioned by other astronomers. For example, there are about 36 magnetars in our galaxy, but for some reason, instruments have not yet detected anything resembling fast radio bursts coming from these sources. There's something to think about, isn't there? Do you like to travel? If so, you've probably encountered unusual travelers on the road who surprise you with their strange behavior. Our Milky Way and the universe are also crisscrossed by busy cosmic highways, where amazing objects appear from time to time. In 2017, astronomers accidentally discovered one of these travelers, a real daredevil, moving at an unprecedented speed. What is this mysterious object? At first, scientists thought they had encountered a huge star traveling at over 850 kilometers per second, or about 3 million kilometers per hour. That speed is unimaginable even on a cosmic scale. What could have accelerated the object to such an extent? And are we really dealing with a star? After carefully studying the celestial body using indirect methods, scientists had to reconsider their initial opinion. What made the astronomers do that? Let's start with 2017. That's when a strange celestial body came into view in telescopes on Earth, and it was almost immediately classified as a white dwarf, on the grounds that, among hypervelocity objects, this type is usually the most common. The unknown visitor was assigned the number LP 40365, but over time, it became clear that the first impression was wrong. Most likely, the swift traveler is not a star at all. What is it really? First, let's recall what characterizes white dwarfs. The stars mentioned consist of electron-nuclear plasma and are completely devoid of sources of thermonuclear energy. So how do they emit light? This happens solely due to thermal impulses, so such stars gradually cool down. However, this process takes billions of years. Usually, white dwarfs do not exceed the mass of the Sun. Their radius is much smaller, sometimes 100 times or more. LP 40365, as many scientists believe, belongs to exactly this type of star. The current location of the object is the constellation Ursa Minor, which is 977 light-years away from Earth. Over 4 years of observation, astronomers have studied it quite well. In particular, they found out what the celestial body is made of. Here, scientists faced their first surprise. It turns out that LP 40365 is mainly composed of heavy elements. At the same time, the spectrum shows almost no helium, carbon, or hydrogen, as is usually the case in stars of this type. But how did this wandering object appear on the invisible lanes of cosmic highways? And what could have accelerated it to such monstrous speeds? The answer to this question turned out to be quite simple. Members of Stefan Venus's group from the Astronomical Institute of the Czech Academy of Sciences believe that an ancient catastrophe set the star on its extraordinary course. There is a possibility that the celestial body was once part of a binary system. Such are the harsh realities of the cosmos. After the star's companion turns into a supernova, the second member of the system usually perishes, but not in this case. Apparently, the explosion lacked the power to completely erase the object from the face of the universe. The supernova instantly destroyed the outer layer of the companion star, at the same time giving it incredible acceleration and, as they say, sending it far away into the night. By the way, this fact is also confirmed by the unusual metallicity of the star. After all, during a supernova explosion, it is heavy elements that are released in large quantities. All this is scientifically proven information, but what we are currently able to observe is not a star. Such a statement was recently made by astronomers. Why do they change their minds so often? We'll try to explain. Most likely, the object we're seeing is not an intact celestial body, but rather a fragment, so-called stellar shrapnel, left over after a cataclysm. Adelia Potterman, a researcher at Boston University, claims that a hypervelocity star that survived after its supernova companion exploded is a unique phenomenon. After all, in 9 cases out of 10, such objects are irreversibly destroyed. It's like surviving at the epicenter of a nuclear explosion. To explain such exceptions, it's worth recalling one small detail. A non-lethal outcome is only possible in the case of type IX explosions. With the much more powerful type Ia supernova, the companion object in a binary system cannot remain intact. In the latter case, even space-time deformation is observed. Naturally, nothing survives in this deadly cosmic wasteland. Most likely, LP 40365 was affected by an IAX explosion and was thrown into space by a monstrous stream of destructive energy, like a weightless tennis ball. When did the catastrophic event occur? According to scientists' estimates, this happened about 50 million years ago at a distance of several tens of thousands of light years from our planet. Unfortunately, such explosions are unimaginably brief, occurring within a few seconds, and modern scientists are unable to record them, so the only thing left is to meticulously study the consequences of cosmic catastrophes. Where is LP 40365 heading now? Jay Hermes, Associate Professor of Astronomy at the College of Arts and Sciences at Boston University, is convinced that its unimaginable speed makes it clear the object will break free from the gravitational embrace of the Milky Way relatively quickly and will leave our galaxy forever. Have scientists encountered hypervelocity stars before? Yes, they have, and as a rule, all of them were completely dead. Mostly these are white dwarfs and neutron stars. It is these objects that often survive major catastrophes, capable of ejecting objects or their fragments. Using data collected by the Hubble telescope and NASA's TESS observatory, it was discovered that the LP 40365 fragment is not only traveling at an incredible speed, but is also spinning. The fact is that the star periodically became brighter and then dimmer, allowing conclusions to be drawn about its possible rotation. When will the remains of the celestial body leave the boundaries of the galactic disk? Considering the very high speed, this will happen in about 5.3 million years. Such observations are very useful because they allow us to understand global processes occurring in the universe by studying a single object. For example, to learn how exactly high-energy events in the cosmos occur and what their consequences are. The results of research related to LP 40365, which is presumably a fragment of a star from a binary system, have been published in the scientific journal, the Astrophysical Journal Letters. At the moment, the object is about 2,000 light-years away from us, rapidly fading into oblivion, that is, into deep space. A century ago, astronomers couldn't even imagine the discoveries that are now widely known or will appear in the foreseeable future. For example, recently physicists faced a problem. Will they have to rewrite the well-known laws and change the familiar physical paradigms? Yes, you heard that right. Our fundamental understanding of the structure of the universe is under threat and may radically change in the near future. Many physicists believe that we are on the verge of discovering a fifth force of nature. We're talking about a virtually undetectable particle called the muon. It should be said that even scientists are not well versed in this matter, let alone the average person. This topic, without exaggeration, is at the forefront of science. This concerns the magnetic moment of the muon, an extremely unstable particle. By clarifying information about this, physicists will have the opportunity to look deeper into the microworld and uncover the essence of processes we previously didn't even suspect existed. For this purpose, as part of an innovative experiment, scientists are measuring the effects of all known particles, and they are doing this with maximum precision. So far, the situation with the usual physical constants has not changed. But who knows? Maybe tomorrow we'll see new physics that can turn our usual understanding of the universe upside down. In any case, the experiment is not over yet. Hypervelocity stars, the magnetic moments of muons, all of this lies beyond what we know, as we are only cautiously beginning to lift the veil on cosmic mysteries. Imagine the situation. You come home and decide it's time to change something. To this end, you fiercely smash the furniture, throw the contents of the trash can onto the floor, stop washing the dishes and cleaning the bathroom, and to top it all off, you turn on the gas. The system is broken, but can such actions really be called reasonable? Humanity behaves in much the same way toward its global home, planet Earth. It destroys wildlife, produces incredible amounts of waste, and pollutes the atmosphere, depriving it of its ozone layer. Given its ability to regenerate, the long-suffering planet that has sheltered Homo sapiens has lasted as long as possible. But lately it has been hinting more and more often that we've overstayed our welcome here. Where should we look for a new home? Is it worth hoping for a Mars colonization mission? Yes, it's been planned for a long time, but the red planet is not Earth's twin, so the difficulties of migration may prove insurmountable. Is there a celestial body that's warm enough, not too cold, with oceans and an atmosphere similar to Earth's? Where can the cradle of humanity's future be found? Look to the constellation Taurus. In March 2018, the Kepler telescope discovered an object in this location, which is believed to have almost the same characteristics as Earth. By a strange coincidence that has occurred recently, the planet with the codename K2155d is located next to a red dwarf, a rather calm but dim, long-lived star. A twin of Earth has been discovered along with 14 other planets, but the conditions on them are unlikely to seem comfortable for the emergence or maintenance of life. The climate and temperature parameters of these objects are unfavorable, if only because their distance from the star is too small. A year on each of them does not exceed 40 Earth days. In such cases, tidal forces come into play, and the planet, being unable to turn away from its star, is constantly roasted on one side. This means that on the illuminated side there is an infernal heat similar to that of Venus, while on the dark side there is cold and darkness. But there is hope. If at least one of these planets is surrounded by a dense atmosphere, the situation will change. Due to the distribution of heat, the temperature in both hemispheres will become relatively stable, although this will cause hurricanes of unprecedented strength. And yet, many astronomers do not believe that there are conditions for evolution to begin on planets that orbit too close to red dwarfs. The absence of a magnetic field and strong flares from the star make the development of life on such celestial bodies almost unthinkable, despite the longevity of such stars. All of this is true, but Japanese scientists say that is not true for K2155d. The Earth-like planet is located in the Goldilocks zone, so the formation of life on its surface is quite likely, although it probably also shows only one side to its star. The object can fit 3 Earths inside it and is located 200 light-years away from us. It's difficult to study the celestial body in detail for now, but NASA has planned a mission aimed at clarifying the conditions on 15 discovered planets, including K2155d. Let's try to imagine what might await us in this distant, unknown world. What if astronomers miscalculated and the planet's conditions are entirely different than assumed? A waterless world. Let's imagine K2155d as a celestial body where water is as solid as diamond, and ancient riverbeds are filled with streams of liquid methane, forming poisonous lakes along the way. It could be a dirty, foul-smelling frozen world where, theoretically, only methanogenic creatures made up of cells based on nitrogen compounds could survive. Not a very appealing picture. That's not life, that's Flint. It's possible that K2155d is extremely hot, and its atmosphere is pure hydrogen with minor impurities. Let's suppose that in this hellish world, there were attempts at forming life, and a trace element from the periodic table, silicon, which is found in many earthly rocks, replaced carbon and became the basis for evolution instead. In the same way, phosphorus could have been replaced by arsenic, and sulfur successfully displaced oxygen. In that case, alternative biochemistry could lead life into uncharted territory, and when astronauts finally landed on the planet's surface, they would be met by scorching lava and extremophiles. Such a warm welcome is not comforting either. But let's set the exotic stuff aside. Still, the conditions on K2155d meet expectations and are at least somewhat similar to those on Earth. So one day, when astronauts reach its surface, they will see an unusual world. They will be met by completely black vegetation, which over centuries has adapted to absorb the full light spectrum more efficiently and has thus optimized photosynthesis. It's possible that the plants on K2155d have developed filters that protect them from the radiation periodically emitted by their parent star. They may have grown larger root systems, so even the fiercest storm couldn't uproot them. On the side that is always facing the star, people will see a vast ocean, land, and mountains illuminated by a ghostly reddish light. Because the sun never sets in one hemisphere, the shadows cast by rocks and vegetation will remain unchanged for centuries. According to convergent evolution, in conditions similar to those on Earth, development should follow a familiar scenario. Therefore, it is possible that the aliens will encounter animals on K2155d as well, small and completely deaf due to the fierce wind. Scientists believe that if the planet is indeed habitable, then most likely it will not be entirely covered by an ocean. After all, in that case, all the substances necessary for chemical reactions would be buried under a layer of liquid. In any case, celestial bodies orbiting red dwarfs are definitely candidates for potential human habitation. Who knows, maybe centuries from now, our descendants, who will be very different from people today, will watch their blood-red sun, which never sets below the horizon, occasionally remembering Earth, a planet long gone into the past. On February 22, 2017, a conference initiated by NASA was held, the results of which could change our understanding of the universe and shake the beliefs of skeptics who think that Earthlings are the only exception in the dead depths of space. So, over a 20-year period of research aimed at searching for exoplanets, a significant breakthrough has finally occurred. In the system of a cold dwarf star called TRAPPIST-1, located 40 light-years away from us, 7 exoplanets have been discovered, where life may exist in some form. 3 of them were discovered by the Spitzer Space Telescope using the transit method back in 2016. This method involves analyzing a star to see whether any objects pass in front of it. Then, titans like Kepler and Hubble joined the research. This newly discovered world is both similar to and radically different from our solar system. In terms of configuration, it is certainly similar to our solar system, since it is based on the same principle as all objects in the universe, starting from the atom: rotational motion of round bodies around a common center of mass, a nucleus, or a star. In all other respects, it is a mysterious world that NASA scientists will be actively trying to unravel over the next 5 years. Of the 7 planets, 3 are located in the so-called habitable zone, so it is assumed that they may have the conditions necessary for the emergence of life. The star they orbit is named TRAPPIST-1a, and the planets are designated by letters, following an alphabetical order. The first is B, the second is C, and so on. TRAPPIST-1a is a cold dwarf, much smaller than our Sun. Everything is best understood by comparison. So let's use the now familiar ball analogy. If the Sun is a basketball, then TRAPPIST-1a is a golf ball, which means it's a star just a bit bigger than Jupiter. Evolutionary processes on this star happen much more slowly because possibly during its active period the planets were somewhat different. The age of the discovered star system is estimated to be about 500 million years. The brief characteristics of the discovered planets, which are currently known to NASA specialists, are presented by the Hubble channel to its grateful listeners. Distance. If interplanetary travel became possible in this system, it would be measured in days rather than years, since the planets are very close both to their own star and to each other. For example, the first planet is located 20 times closer to TRAPPIST-1a than Mercury is to the Sun. Accordingly, we're talking not about hundreds, but tens of millions of kilometers. A view from the surface of an alien planet. The neighboring planets can easily be seen from one another, since from each planet the next one is clearly visible in the sky. Moreover, if an Earthling were standing on the surface of, say, TRAPPIST-1ef, then TRAPPIST-1e would appear on its horizon as an object several times larger than the Moon. Moons. The discovered planets most likely do not have any moons. But their absence does not mean that if there were water on the planets, tidal forces would not be at work. Due to their significant proximity, the familiar tides we know could also exist on these distant worlds. The discovered planets are quite comparable to Earth, with only minor deviations one way or the other. One-sided position. Due to tidal locking, all the planets in this system always show the same side to their Sun, just like our Moon. This allows for a much wider range of temperatures, which creates the conditions necessary for the presence of liquid water. Planetary conditions. Of the 3 planets in the habitable zone, the largest is TRAPPIST-1g. It is 13% larger than Earth, and a year on it lasts 9 Earth days. It receives about as much starlight as Mars does. TRAPPIST-1f is presumed to be a water world, although there is no evidence for this yet. The orbit of the closest planet to the star, TRAPPIST. One lasts only about 2.5 days, while the farthest one takes about 20 Earth days. After the discovery, the planetary system was observed in more detail by the TRAPPIST telescope, and based on its data, people on Earth can get a small idea about this world. Next, the advanced James Webb Telescope is expected to join the observations, which is capable of closely studying the molecular composition of the atmospheres of the discovered planets. And this will help form an idea about the presence or absence of life on them. Of course, the first thing that comes to mind is the possibility of traveling to these alluring worlds to see for ourselves whether they are cold or boiling, rocky or gaseous. But the first target for Earthlings, provided a modern spacecraft is designed, is the Proxima Centauri system. But to reach the distant cold TRAPPIST, one even at the speed of light, it would take 40 years, and at an airplane's much slower speed, the journey would stretch out to an unimaginably long 44 million years. But the fact that the scientific community keeps making relentless progress gives us hope that very soon we will see with our own eyes things we couldn't even dream of before. In the meantime, maybe together we can come up with names for the nameless discoveries.
Friends, I ask for well-reasoned comments.
And what if the channel?
If our unique style caught your eye, feel free to subscribe.
Subscription links are on your screen and in the description. Subscribe.